Hi, my name is Lochin Kit. My project title is Smart HVAC System. It is developed based on the Smart Office template from the Thingsboard platform. The biggest differential of this application from a normal HVAC system is that this system does not control the air conditioning and fan speed at a absolute temperature values or speed values. Instead, it operates according to the user's subjective thermal feeling of the environment, and also depends on the outdoor condition, such as the regional relative humidity. Here is a graphical user interface program written in Python. So let's run the program. So as you can see, it is a program that simulates an application in smartphone or tablets that user can control their HVAC system remotely in their network. In the background, it also simulates the sensor values which are installed in the office or buildings or apartments. As you can see, there's a on-off switch for the HVAC system and 5 different options for the operating mode. User can click the mode after the HVAC is on according to their thermal preferences. So let's say now I feel a little bit cold, so I want the environment to be slightly warmer, so I will click the little warmer mode. Or I feel very hot now, I want a colder environment, then I will click colder button to switch to colder operating mode. So how this program works is that the program will calculate the optimized target air temperature of the air conditioning and the fan speed according to an enhanced PMV model, which is validated by a published paper. And also it also depends on a regional relative humidity that is extracted from a from the Hong Kong government open data platform using the API in real time. So let's see how it works. So when I click switch on, you can see it immediately turn on the HVAC system accordingly, and initially it will be operated at a natural operating mode, and you can see the airflow velocity and the target temperature is set accordingly to the enhanced PMV models, and also depends on the relative the regional relative humidity extracted from the open data base. And now let's say I feel a little bit cold, so I want a slightly warmer environment. I'll click to warmer. As you can see, the mode changed to a little warmer, and then the airflow increased it, and the target temperature also increased it accordingly to the enhanced PMV model. So here the dashboard also shows the temperature and the power history of the HVAC system. Then the user can review this data to see how the environments are being operated according under the HVAC system. And also if they want to see detail, then they can click into this, navigate to this sub dashboard, and they can see all the power consumption and also the voltage and the currents, so that for individuals and business, they can understand their power demand and their budget on the power spending. And also they can see when did they spend all the energy, and then they can, after they review all of these statistics, they can think about a more effective way on the power saving pan. And also they can also check the data about the HVAC system, like the history of the target temperature and the airflow, and history of the on-off states. And also they can check all the sensor value to check whether the temperature and the humidity is operating and normal, and also to check the air quality as well, and check the occupancy. And there is also two alarms have been set in this application, which is high temperature and low temperature alarm. For the high temperature alarm, when the temperature is raised to quite a non-acceptable degrees, then it will trigger this alarm, and then it will clear after it raised down to a certain level. And for lower temperature, it operates in the same principle, and also it will be clear when it raises up to a certain level. Again, the best thing is that this application, for the user, they can select their preferred thermal environments that they want. So that because usually for people who come from a hotter place, they are usually for a normal HVAC system, they will just switch to the lowest temperature, which is not healthy for them and also wastes a lot of energy. But instead, if they are using this application, they may save some power budget, and also they can understand their usage, and also they won't waste too much energy on an unnecessary need.